Hello everyone and welcome back to School of Solana. One of your graduation requirements is to build a full-stack Solana dApp. We already showed you how to build a program in Anchor in the previous lessons, but we did not show you how to connect that program to a frontend yet. So that's what we'll be working on today. We'll be making a ticket registry program which will allow users to create events, buy tickets for those events, and it will also allow event creators to withdraw funds they made from selling tickets. If you like to code along with the lessons, this one is perfect for that, because I'll be using our School of Solana Docker image, which has a pre-configured environment, and I also prepared tests and custom error messages in advance so we can focus on the actual development. Instead of using the Anchor initialize command to initialize our project, we will use a tool called create-solana-dapp. This is a tool which will create for us not only an Anchor project, but also it will create a simple front-end template which we'll use in the second part of the lesson. So let's copy this command and initialize the project. We'll use the basic template and now we'll wait. I'll be right back. The project is finally initialized, so like last time, first I'll create program structure. First, we'll definitely need the system program because we'll be creating an account. We'll need an event account because we'll be creating an event with this instruction. But we do not have event account created yet. So let's go do this. And alright, let's think about this. So we definitely need an event name. And the name will be string. Let's also add event description, which will also be a string. Then we will need a ticket price. Let's do U64 because it will be in LAM ports. Then we will do number of available tickets. We also need to store the event organizer. And last but not least, we need timestamp when the event is supposed to start. Okay, is that all we need? We have name, description, ticket price, number of available tickets, event organizer, and start date. We'll also use init space macro to calculate space for our account automatically. Let's also specify max length. So for name, we'll do 30. And for the description, let's do like 300. All right, and by the way, when you use the init space macro and you specify the length of strings or vectors and other dynamic data structures, you also want to manually verify within the instruction that these attributes have the desired length, because this macro at the top does not verify the actual length of the string. It is there just to specify how many bytes the program should allocate for this account. So just keep that in mind. We'll get back to this later. I have a test prepared for this. But since we'll be also verifying length of these attributes within the instruction, let's use a constant instead. And let's get back to our initialize instruction. So now we can import the event account. We also need the event creator or organizer, pub event organizer, and this account will be the signer. Alright, these are the accounts. Now for the constraints. Signer is simple. All we need is to make the account mutable, because this account will pay for the account creation. Then let's initialize the event account. Pair will be the event organizer. What else? Oh, we need space. So discriminator plus the event init space. Now for the seeds. Whenever you're picking seeds for your accounts, think about it really hard, because we can use them to make our lives easier and verify some things for us without having to do it manually. So first, let's do event, and we want every event organizer to be able to create exactly one event with a certain name. So let's do event organizer.key as reference, and we also need to retrieve the name of the event, but we do not have the parameter yet. Instruction, we want the name string. Cool, so let's also add the name as bytes, and we also need the bump, and I forgot the comma. Okay, one more time. So since we have name as well as event organizer key specified within the seeds of the event account, this means that every event organizer can create only one event with a certain name. If we removed the event organizer key, then that would mean that there can ever be only one event with a certain name. If we went further and also removed the name from the seeds, then we could only have one event in total, and whoever creates it first will have the only event. We do not want that, so let's return the seeds. And now we'll implement the initialize instruction. So the instruction should be pretty simple. All we need is to basically initialize fields of the account. So let's do let event mute context.accounts.event. So now let's manually verify that the length of the name is correct. And if it's not, then we'll return an error. In advance, I prepared a few custom errors, so I'll add them right here. And we'll use the name too long error. So return ticket registry error, name too long, event name is equal to name. Now we also need to verify the description length. We do not need to verify the ticket price. Tickets could be free, for example, so that should be all right. We need to definitely verify the number of available tickets. I guess it wouldn't make sense to create an event with no tickets. Start date, and the start date should be sometime in the future. So let's do clock get this, and let's do Unix timestamp. And if the start date is too low, then we will throw start date in the past error. Start date. All right. 1, 2, 3, 4, 5, and we're missing the event organizer. Context.accounts.event organizer.key. So that's it for the initialize instruction. All we do is just create the event account, verify the parameters, and then initialize it. So now we'll create the buy ticket instruction. All right, so the first account will be buyer. He'll be the signer, and he'll also be mutable. Then we need the system program because we'll be creating a ticket account. We need the account of the event for which we'll be buying the ticket. So let's make it mutable because we'll be updating the number of available tickets. Now let's add the ticket account. Pub ticket account. And we do not have the ticket account yet. So let's rename the struct ticket. And what will we store? Let's store the address of the event. So we can remove this event and we'll store pub key. Then we should also store the pub key of the buyer. And last but not least, let's store the ticket price. Pub price U64. We do not need to specify length of anything else. And that should be it. So let's import the account. And now we need to create it. Account init payer will be the buyer. Space, once again, we need the discriminator of the account plus ticket init space seats and also bump. Okay, first we'll do ticket as the first seed, and now let's think about it. What do we want? So we want each buyer to be able to buy one ticket per event. But we do not want to verify that manually, because that would be additional work, so let's use seeds to do that. So first we'll include the address of the event as reference, and then we also need to include address of the buyer, because if we left the seeds like this, then there could only exist one ticket per some event. So let's add the buyer. So once again, we just need to initialize the ticket account. So let's do ticket. Oh, first we need to take the account. Ticket dot event is equal to event dot key. Let's do price, and this will be equal to event dot ticket price, and ticket dot buyer will be equal to buyer, but we do not have the buyer yet. Buyer dot key, like so. And what else? Well, let's verify a few things first. For example, we should make sure that buyers will not be able to buy tickets for the events that already started. So let's do require event.startDate should be greater than the current timestamp. Clock get sysvar Unix timestamp. And in case they attempt to do that, let's return an error, which will be start date in the past. Let's also make sure that we cannot buy tickets if the event is already sold out. Available tickets greater than 0. And we should have error for that as well. All tickets sold out. Nice. So we will check the number of available tickets, and we also want to update the number of available tickets. Event dot available tickets dot checked sup 1, and this will be event dot available tickets is equal to this. And let's unwrap. It will panic if it overflows. Then the user should also pay for the ticket, so we'll need a CPI. So we'll do CPI context is equal to CPI context new. The program will be the system program because we are transferring LAN ports. System program to account info. Oh, we also need to add the system program. Account info. Let's also specify the account. Program. Which one? Transfer. And the accounts are from and to. From will be the buyer. To account info, and to will be the event. So let's call the CPI. Transfer CPI context, and LAN ports will be the event.ticket price. So one more time, first we verify some things, then we transfer the LAN ports from buyer to the event. We also updated the number of available tickets, and last but not least, we initialize the ticket account. So now all that's left is the final instruction, which will be the withdraw instruction. This instruction should be very simple. All we have to do is withdraw funds from the event account to the event organizer. This time we do not need a system program, we definitely need the event, and it has to be mutable. And we also need to verify that the signer is the event organizer. So we'll do S1 event organizer, but now we also need to name the signer event organizer. And since event account is owned by our program, we do not need to use the CPI. We can just update the number of LAN ports manually. And event organizer.add LAN ports, and we'll also do amount. Okay, so the program should be finished, and now we will test it. So once again, I prepared a few tests of camera. The tests will be available in the project linked in the video description. So let's try to run them. Oh, and this will take a while. I'll be right back. Alright, like last time the build failed because I do not have the key pair created on this image yet. So let's do that. Solana keygen new. And let's try to run it again. Alright, seems like we ran into another error. So let's try to install this dependency. Right, anchor test. So this time all of the tests passed. And let's get back to the init space macro, because I told you that it is necessary to also verify the length of strings manually within the instruction, because this maxlen macro does not verify it by itself. So let's try that. I will comment out this check and let's try to run the test again. So this time, as you can see, the tests failed, and the event description was longer than it should have been. As you can see, here is the number of letters that the description contained, and here is the maximum expected length. We built the program, we tested it, and now let's deploy it on the devnet. So we'll run anchor deploy. Let's go here and change cluster to devnet. Will this fix it? And it appears that I do not have enough SOL in my wallet, so let's airdrop some SOL. Usually, when you try to airdrop SOL manually through the CLI like this, you'll run into this error stating that the rate limit is reached. So I recommend using the Solana faucet instead. Let's airdrop 5 SOL. Airdrop was successful. So now if I do Solana balance, so the balance still shows that I have 0 SOL, but I think that is because I did not set my config to devnet in the CLI as well. So I'll run Solana config set URL devnet, and now when I run Solana balance, it should show that I have 5 SOL. Nice. Anchor deploy. The program got deployed successfully at this address, so now anyone can interact with it on DevNet. And now that I think about it, I tried the airdrop command before I set the config to DevNet, so let's try it again just to see if it works. Yeah, and for example, this time it worked. Let's also add the program ID right here. So we have localnet. Let's copy this and change this to DevNet. DevNet. And also let's update the address right here. And now, since we changed this address in the source code, we also need to redeploy the program again. So let's do anchor deploy. Create-solana-dapp also includes a very cool tool called Codama. And basically, Codama is a tool that we can run, and it will read IDL of our program and generate a client library through which we can interact with our program. So, for example, we'll be able to call functions which will build the instructions for us, and it will simplify the whole process. You'll see in a sec. So currently we're in the package.json file, and right here is a script called setup, which will sync our keys, although we just did that manually, and then it will run Codama, and Codama will generate the library for us. npm run setup. Right here is the client library, but Codama is not perfect and sometimes it makes mistakes. For example, right here it did not fill in our program address correctly, so let's fix that. And also make sure to check that seeds of the functions which will create the instructions for us, we'll use this in our frontend, are set correctly. For example, right here, we should have just the name of the event as bytes as a seed, but it adds some prefix in front. Let's remove this. I also checked the other two instructions and they seem to be generated correctly, so let's start working on the front end. npm run dev. I opened the page, but we are currently getting error because we updated our program as well as the client library and it no longer fits the default template. So let's fix that. So let's comment all of this out. For now, we'll fix it in a bit. So this is what the default page looks like. We can also connect our wallet, and this is where our program will be. First, let's update the feature page. We can also simplify this one. Let's do return. We will have a div with div inside. Let's do a heading. And it will be our ticket registry. And right here we'll add our own component. So first we'll create a component through which we can create events. So let's do create event. We'll close it. Let's also remove this import. This is what the page currently looks like. So let's add our component. Export function, create event. And let's create a simple form. So we'll do return app model, specify title, create event. We'll also put in the submit function, which we'll create also a bit later. In order to set the value, we need a hook. Const form data set form data is equal to use state. Our event will need to have a name. We'll need a description. We also want start date, ticket price, and I think the last parameter was available tickets. We do not have the submit yet. Wait, let's comment this out and take a look at what it currently looks like. So I'll connect my wallet. Right here we have a button, and when we open it, we have a form. So now I will quickly finish rest of the fields and I will be right back. I added rest of the form fields and this is what it currently looks like. So we're also able to set the date, the price of the ticket in Lamports and available tickets. So now we need to create the function with which we'll submit the form and call the create event instruction. So first we need to retrieve the signer from the wallet. Signer is equal to use wallet UI signer. And we also want the client through which we'll submit the instruction. No. Use wallet UI, this one, dot client. So we have the client. Now let's create the submit instruction. Handle submit const instruction await get initialize instruction async event organizer will be the signer. So right here we created the instruction and now we need to submit it. Let's create a function for that. Process transaction. We'll need to pass the signer. Transaction signer. We'll also need to pass the client. And last but not least, we need to pass the instructions which we want to process. Create transaction. So first let's get the latest block hash. Latest block hash. Then we will do fee pair. Fee pair will be the signer. Version will be legacy. And we need the instructions. And that is it. So now let's sign and send the transaction. Transaction. Let's use this function right here. Process transaction. And right here we will call process transaction. We will pass in our signer, client, and instruction. And after that we want to reset the form. Let's also retrieve the signature and do console log. And let's try it. Because they'll fill in some name, some event description. Now let's choose some date in the past. I mean in the future. Ticket price. We'll do just a few imports. And available tickets. Let's do 10. Save. And we have a problem. Alright, I'm back. I fixed the error by taking the time that user inputs in the form and then I converted it into seconds. Create some name, description. Now we choose some date. Wait, this is in March. We need something in the future. And let's click create. Now I need to sign the transaction. And if we check the console, yes, there it is. But the signature which we are logging is currently in the wrong format. So let's fix it. So let's get the decoder first. Const decoder. Okay, this should fix it. Let's create a name, description. So now we can verify the transaction on Solana Explorer, and as we can see, it went through. The create event instruction works. Right now we are able to create events, but we still do not have a component which is able to fetch all of the created event accounts and display them on our website. So first we'll create a function with which we will fetch all of the event accounts. Export async function get and accounts. And what will we need? We will need client, Solana client, and let's also add the program ID. First, we need to fetch all of the accounts. Const all accounts await client rpc dot get program accounts, and we need first the program address, so program ID, and then we need to specify encoding. We'll use base 64, and then we'll do send. Now we need to filter all of the accounts that we fetch, because this will fetch not only the event accounts but also tickets. Well, we'll filter these accounts based on their discriminator. So let's fetch the discriminator. Let's decode these accounts. Okay, so first we fetch all of the accounts, then we filter those accounts using the event discriminator, and then we decode all of the event accounts and return them. So now let's display these accounts. First we'll add a component. Let's do event list. And now we need to add it. Function event list. We'll need a client. Use wallet UI.client. Then we will need the program ID. Let's also use a hook to store our events. Now let's add the component. So first we'll display the event name and .data.name. Then we'll display the event description. And now let's also display a few properties like price and number of available tickets. Let's do span price. Price will be in lamp ports. And it will be event.data.ticket price. Right here we'll have available tickets. And data.available tickets, and right here will be the start date. We'll also need to convert the start date to the actual date because we store it as seconds. So new date number times 1000 dot to local string. Okay, let's also separate these. Forgot to add the key index. We do not have a way to retrieve the events yet, so let's add a refresh button as well. Click this. Yes. We retrieve all of the events. Nice. There are 5 events in total because I tried to create a few off camera to test the implementation. Right, so we are able to create events and retrieve them, but we still have no way of buying tickets and withdrawing LAN ports collected by selling tickets. So let's work on that. First, we'll add the buy button. Let's add it under the event information. Buy ticket, and we will pass the event address. And let's also add the withdraw button as well. Withdraw funds. And we'll also need the address. All right. Function buy ticket. So once again, we'll need a signer. Use wallet UI signer. Then we'll need the client. Let's take this one. Then we'll return a button. Buy ticket. On click, we will have a function. So let's do buy ticket. And now let's implement the function. Const buy ticket is equal to async. We'll need to create the buy ticket instruction and then process it. So first, const instruction await get buy instruction async, the one generated by Codama. So event will be the address we get as a parameter, and buyer will be the signer. Now let's use our process transaction function. So we'll pass in the signer, client, and instruction. Now let's add the withdraw funds. So we have signer, we have a client. Right here we will have withdraw get withdraw instruction. Right here we will need the event organizer. event and amount. So event we already have. The buyer will be the event organizer and amount. We'll need to somehow retrieve amount from the user. So let's use a hook again. Amount, set amount, use state, and we will create a simple input field where the user will be able to specify amount of lamports they want to withdraw. This will be big integer amount. I forgot the comma. So let's try it out. Ticket costs 20 lamports. Let's buy it. I will sign the transaction. And looks like the transaction went through. So let's inspect it in the Explorer. We paid the price of 20 lamports. We also paid for the transaction. And it works correctly. Let's also try the withdraw. Since we are the event creator, we should be able to do that. If we refresh, the number of available tickets should also decrease. Yeah, so now there's 23. Let's do withdraw. The ticket cost 20 lamports. I will sign again. Let's also inspect this transaction. Yes, and now we withdrew the 20 lamports back to our account. Right now, this dapp does not look very good, so off camera I prepared a simple style sheet, so let me quickly implement that. I added the style sheet, and this is what the final dapp looks like. The GitHub repository for this project will be linked in the video description. Okay everyone, that is it for today. If you've made it this far in the video, you should have no problem completing the Solana program assignment. And also, make sure to do your best, because we will be selecting the best submissions to showcase on the graduation call, so that everyone else can also see what you've built. As always, if you have any questions or need help with the programs, feel free to reach out to us on Discord. I'll be looking forward to your submissions and see you next time.